Hey guys, hope you're doing well. In this series, I'll cover design and analysis of algorithms. By the end of this series, you'll have a working knowledge of how different algorithms work and how to implement them. For the implementation part, I want you to have the basic knowledge of C++. If you don't have it, it's fine. So without further ado, let's get started. This is the book Introduction to Algorithms that I'm going to be using. I'll put the link to this book in the description. So if you want to check it out, follow the link. So the definition of algorithm say that it must have a finite set of statements and it must end in a finite interval of time, guaranteeing an optimal solution. This means that an algorithm must not continue to run indefinitely. It must guarantee an optimal solution and at some point it must stop. Definitors say that each instruction must be clear or bug free. Also, the algorithm must be general, means that the algorithm must work for any given inputs applicable to the problem at hand. For the analysis of algorithms, basically there are two types of analysis. There is theoretical analysis and then there is practical analysis. For theoretical analysis, you theoretically analyze your algorithm. For example, if your code is going to run for n iterations, then you can deduce that your theoretical complexity of the algorithm is going to be big of n. So you are making a calculated guess. For practical analysis, you translate your algorithm into code and test it on an actual machine with varying inputs of varying sizes. The graph you see is of different sorting algorithms. You can see that it has an input size on x-axis and y-axis has running time. The best average case and worst case show the how the array is. For example, the best case is that the array is completely sorted, and average case is that it is partially sorted, and worst case shows that it is like in reverse order. So you can see how the bars show the running time is measured. The three asymptotic notations that are given here are used to represent these complexity of different algorithms. The first one, which is theta, it is the average case. Then big O is basically the worst case, and omega is the best case. So this is the graphical representation of how algorithms grow under different scenarios such as best, worst, and average. The first diagram you see is that Fn is an average case and the line is in between C2GN and C1GN, which are worst and best cases. When you are reporting the complexity of an algorithm, you must report the average complexity because for varying input sizes, the algorithm that was performing best in some scenarios might perform worst for other input scenarios. So it is best practice to report the average runtime, which is theta. Now let's reduce the theoretical complexity of this given code, which finds the sum of the given array. The operations at 1, 2, and 8 are executed once, while the operations that are inside the loop, the 3, 4, 5th, and 6th, and 7th, are executed n times. So if we combine them, we get a total complexity of 5n plus 3. So that was all for this video. Don't forget to like and subscribe and share with your friends, and see you in the next video.